right, algebra students, so today is the last of the rules of exponents. And so if you think back to where we have been, remember there's 5 total, but really just 2 main categories. So the first 2 rules we learned are what do you do when you have like bases and you find the product. So this is what we call the product rule, and remember you add the exponents. The second rule was similar, what you do when you have a quotient, and remember you subtract the exponents. And then early this week we've been working with the power rule, and the power rule says that you multiply the exponents together in order to solve when a power is being raised to a power. And then we learned how to apply that to product and quotient. So those are our 4, sort of the first 2, product and quotient, and then the power rule, product and quotient. And so today is the 5th and final of the rules. And today we're going to be dealing with negative exponents. Now, if you worked on IXL, you may have accidentally run into a negative already. And today we're actually going to learn what to do with them. All right, negative exponents. So first, let's just look at a pattern. All right, so we're going to use the first 1, 2, 3, 4, 5, 6, 7. We're going to use the first 7 lines. So you can just sort of block off 7 lines here. And we're going to create actually 2 different sort of lists, 2 different patterns. And so you've probably seen something similar to this before. So let's start with just, a regular positive exponent. So up here at the top, we know that 2 to the 3rd power is the same thing as 2 times 2 times 2, which is 8. I don't think anybody would fight me on that one. And then, if we keep going, let's look at another in the same sort of family of exponents. We have the same base, but we're just going to lower the exponent by 1. So 2 squared, would we know, is 2 times 2, and that would be 4. And then let's just keep lowering the exponent, because remember, we're talking about negative exponents. So notice where I'm going with this. This is 3, 2, 1. Well, 2 to the 1st power is just a 2. And that would just be 2. A 2 one time. And then 2 to the 0 power is where we start running into, well, what does that even actually mean when you raise something to 0 power? We've had this discussion before. We did it on the very first day of our notes page. But just as a reminder of why this works, if you think about what's the pattern that's happening here. So this was 2 times 2 times 2. This is 2 times 2. This is 2. Every time we have 1 less times 2, and if you can think of it as like getting rid of one of the times 2, if you think about the opposite of division, or the opposite of multiplication is division, right? So one way we could think about losing one of these times 2s would be to divide by 2. Right, and it makes sense because 8 divided by 2 is 4. We're losing a times 2. And then 4 divided by 2 would be 2. We're losing a times 2. And so when we get to this point, we think, okay, well then what would 2 divided by 2 be? Every time I'm losing a times 2, well, if I have a 2 and I lose a times 2, then I actually only end up with 1, right? And I'm just going to write the final answer there. So 2 to the 0 power is 1. And so if I continue this pattern into my negative exponents, so 2 to the negative 1, 2 to the negative 2, 2 to the negative 3, let's say, what ends up happening is that I just continually divide by 2. I'm just going to keep this pattern going. Well, what is 1 divided by 2? Well, it's 1/2. All right, and I'm going to write it as a fraction. It's going to make a little more sense if we write it as a fraction. And then what is 1/2 divided by 2? Well, I mean, we could work it out longhand if we needed to, but if you think of half of a half, cutting a half in half is a 4th. And then if I divide by 2 one more time, I actually end up with an 1/8. And so I want you to see this relationship between what's sort of happening. I put equal signs here. What's sort of happening here when I have a positive exponent versus what's happening when I'm having a negative exponent. It really just ends up being the positive exponent on the bottom, all right? So 2 to the 3rd power was 8. 2 to the negative 3 power is going to be 1/8. So what ends up happening when I get into negative exponent land is I actually end up just putting 1 over the positive version of this exponent. So this would be like 1/2 to the 1st, which is 2. and 1 over 2 squared, which is 4, and 1 over 2 to the third power, which actually ends up being 1/8 because 2 to the third power is 8. So I actually it was explained to me once like this: if you see a negative exponent, that negative exponent is begging you to be put downstairs. So a negative exponent just means we flip something into the opposite. Since these are in the numerator, we flip them down into the denominator. So the same thing's going to happen today with variables, right? Because we're not dealing with numbers, we're dealing with variables more often than not. So if you think about, let's do the same sort of idea: x to the third, x to the second, x to the first, x to the 0, x to the -1, x to the -2, and x to the -3. Of course, there's nothing really to do to these first ones. I mean, we could expand them, sure, but x to the third is just x to the third. X squared is just x squared. X to the first is just x to the first. X to the 0, anything to the 0 is just 1. And then when we get here, we just start flipping things upside down. This is going to be 1 over x to the first. Or you could rewrite that as 1 over x. This one's going to be 1 over x squared. And that's it. We can't, we don't want to rewrite it anything. This was just getting rid of that to the first power. And this is going to be 1 over x cubed. So by flipping it into the denominator, we're able to make that exponent positive. So the rule, I guess that we could say here for negative exponents, so let's write rule. A negative exponent is equal to a positive exponent in the denominator. So if you have a negative exponent, we're going to make it a positive exponent in the denominator. Now, if you're dealing with a number, of course, that's going to actually, just like these 2 to the third power, it's actually going to come out to be a number in the bottom. If you're dealing with a variable, it's actually just going to land in the denominator. So, for example, we might have something like, you might just see, let's just do example number 1, x to the -7th power. And you would say, okay, and most of the time instructions will maybe say write this with positive exponents. And so you would say, okay, that's 1 over x to the 7th. Or you might see, let's do example number 2, a to the -10th. And you would say, oh, that's 1 over a to the 10th. Now, if it's a number, so I'm going to go over here, example number 3. If it's a number, so let's say we did 4 to the -3rd power. You're going to want to actually solve that. So you can go ahead and flip it 1 over 4 to the 3. But then you're going to want to actually evaluate that and figure out, well, what is 4 to the 3rd power? And 4 times 4 times 4, again, type it in Desmos, type it in a calculator, is going to be 64. So this is actually 1 over 64. And so one more example like that. What if we did 2 to the -7th? So as a positive exponent, that will be 1 over 2 to the +7th. But then I'm going to have to figure out, well, what is 2 times 2 times 2 times 2 times 2 times 2 times 2? And, oh, does that come out to be 64 as well? That's weird. It does. Guess that makes sense. To the 64th power. 1, 2, 3, 4, 5, 6, 7. No, it doesn't. It's 128. Y'all were like, just trust in me. That's 128. I was like, there's no way it can beat 4 to the 3rd. 1 over 28. All right. So that is dealing with negative exponents as far as variables and numbers if you have just a variable and a negative exponent. But let's, of course, look at what happens when things get a little more complicated. So let's just jump into an example. Well, actually, I'm going to leave room for a rule because there is a second rule about negative exponents. So leave 2 lines, but we're going to jump down here to example number 1 in this category. So what if I have 1 over m to the -2nd? So what if the negative exponent is actually already in the denominator? Because our whole point here was flipping it down into the denominator and making it positive. So what happens if it's already down there? Well, if a negative exponent wants to be flipped down into the denominator to be made positive, negative exponents in the denominator want to be flipped up to the top. And so 1 over m to the second power actually is begging you to flip it up to the numerator. Well, if I flip it up to the numerator, it's just going to be m squared, and it's going to be over 1, but I really don't even need to put it over 1. I mean, I can, but that's just going to rewrite to m squared. So negative exponents in the denominator end up being positive in the numerator. So we're going to write that as a rule. A negative exponent in the denominator is a positive exponent in the numerator. All right, and so let's do a couple more examples like that. So example number 2 would maybe be something like 1 over x to the negative 5th. Well, I look at that and I say, uh-oh, negative exponent, it needs to flip into the other denominator or numerator. It's already in the denominator, so I'm going to flip it up to the numerator. So it's going to be x to the 5th. That leaves a 1 downstairs in front of that, and so I don't even really need to write anything. I just make it an x to the 5th. Now, it gets really fun when we start seeing problems like this. So what if we have y to the negative 2nd over x to the negative 3rd? So in this case, we have a negative exponent in the numerator and the denominator. And what makes it fun is that this y to the negative 2nd is begging to go downstairs. It's negative upstairs. I don't know if this ever happens at your house, but sometimes, especially if you have a 2-level house, sometimes if you're you're being real ugly and you're fighting with your brother or sister downstairs in the first level, your parents will say, hey, go upstairs and cool off, right? They send you to a different level of the house to get rid of your negative attitude. Same thing happens. You're upstairs, you're upstairs fighting with your little brother or sister, and your parents hear it, and your parents are like, hey, go downstairs, separate, go to a different level of the house for a while and cool off. And so that's what's happening here. We got Y's got a negative attitude upstairs, X has got a negative attitude downstairs, and so we're going to send them to the other level of the house. So the Y to the negative 2nd is going to go downstairs. His attitude gets better. He gets positive. And the X is going to go upstairs and become positive. And so you just flip the position that they're in. So let's do one more of those. I'll do it over here. Example number 4, and let's do it with a number. So we actually have to evaluate something. So let's do 2 to the negative 2nd and times a to the negative 4th over b to the negative 1. And so all we're going to do is flip everybody who's negative. Oh, I should have added something that wasn't negative. So let's put a c to the 2nd down here in the bottom. And let's just look at what happens when this guy's actually in a good mood, right? Everybody else in this house is negative except for him. And so the 2 to the negative 2nd power is going to want to go downstairs to become positive. So he goes downstairs. His exponent becomes positive when we move the level from numerator to denominator. A is going to now become positive down in the denominator because it's changed levels. B is negative and wants to go upstairs. So B is going to become to the positive first. But C is already positive. C is not having any need for any attitude adjustment. So C is actually going to remain. So if you have a positive exponent combined in with a bunch of negatives, you don't want to move him. He stays. And so we have to do a little bit of evaluating here. B to the first is just going to be B. So you end up with B on the top. 2 squared, of course, is 4. So any kind of number base is actually going to need to be evaluated. And then we have A to the 4th, C to the 2nd. And everybody's positive if everybody's happy. And so that is what happens when you have negative exponents. Good luck with your practice.